Hello, geometry, and welcome to lesson 4 of topic 1. We are talking about inductive reasoning, right? So this idea of reasoning is a huge part of geometry and kind of math in general, right? You know, a lot of stuff we do in math, we call it memorization, right? But it's really pattern based and it involves reasoning, right? One step to the next, logical thinking. Um, So nothing changes here in geometry. It actually probably gets used even more so than any of the math class you've had in your life so far. So it says, example 1, use inductive reasoning to extend a pattern. Inductive reasoning is a type of reasoning that reaches conclusions based on a pattern, specific examples or past events. So again, inductive reasoning is based off of patterns of the past, right? So how can you use inductive reasoning to determine what appears to be the next two terms in the sequence? So if we take a look at these numbers, we have to try to find a pattern from one term in the sequence to the next. So what is happening from 88 to 82? Well, we are actually subtracting 6, right? 88 minus 6 is 82. What's happening from 82 to 76? We're subtracting another 6. And the same thing, and the same thing. So obviously the next term is going to be 6 less than 64. 64 minus 6. That next term would be 58. And then the next term is going to be 58 minus 6 again. And this would be 52. 52. Sorry, it looks like an 8 again. 52. And that would be your next two terms in this pattern. Okay, part B, we'll do it in blue here. So what's the pattern? So again, it looks like here, looks like we're growing by 2 from 3 to 5. And then from 5 to 4, or 5 to 9, we grow by 4. And then from 9 to 15, we grow by 6. And then from 15 to 23, we grow by 8. So you can see that each time we're increasing by 2, we're adding 2 on to the previous addition, if that makes sense. So for 23, we're going to add 2 more than 8. So now we're going to add 10. And that would be 33. And then for the next term after 33, we're going to add 2 more onto 12, or onto 10, which would be 12. And 35 plus 12 is 45. And there would be the next two terms in those two sequences. So again, using patterns, finding a pattern and getting the next result. All right, example 2, use inductive reasoning to make a conjecture. A conjecture is an unproven statement or rule that is based on inductive reasoning. So a conjecture, it's very important to understand it's an unproven statement. I like to think of a conjecture as an educated guess, right? Now, usually it's a trend. So like you're using, like I said, pattern, multiple instances to then develop a general rule or pattern to describe the pattern. So I like to think of it as an educated guess, right? Because you're thinking through the pattern. So the question is, what conjecture can be made about the number of dots in the nth term of this pattern? When we talk about nth term, what we're talking about is a generic term, right? So we have specific terms: the first term, second term, third term, fourth term. We want to know what's going to happen in the nth term. What would happen in the 10th term, the 21st term, right? Give us an idea. So what I would do here is I would go ahead and take a look at each term and how many dots there are total and try to look at the pattern of the picture and all that fun stuff. So let's just look at the dots total. So for term 1, right, we have 2 dots. For term 2, we have 6 dots. So that increased by 4. For term 3, we have 12 dots. That increased by 6. For term 4, we went from 12 to 20. That increased by 8. So you can see that each time we're growing, this is similar to the last one, we're growing by 2 from the previous addition, right? So 2 more than 6 is 8, okay? So the 5th picture, right, would have 10 extra dots, so plus 10. Give me a second, let me make that better. So plus 10, so it would have 30 dots. Now, how would the pattern be arranged? Well, I did kind of a row by column kind of assessment. So rows go side to side, columns go up and down. So in this first one, there was one row and there's 2 columns, 2 C's. In the next one, there are now 2 rows and there are 3 columns. The next one, there are now 3 rows and there are 4 columns. The next one, there's now 4 rows and 5 columns. So in the next one, I believe there should be 5 rows and 6 columns. So 5 rows of 6 dots each. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that would what the pattern would look like, right? So if you look at these numbers up here, notice that the 5 for the term number corresponds to the 5 in the rows. And then the 6 in the column number is just one more than the term number. So in my thought process for the nth term, right? For the nth term, there is going to be n rows and n plus 1 columns. And now notice the total sum compared to these two numbers. What's 1 times 2? That's 2. What's 2 times 3? That's 6. So what are we doing? We're taking these two numbers and we're multiplying them together. So we're taking the number of rows, the number of columns, and multiplying them. So to find the nth term, which we would describe as, to find the nth term, I won't describe anything else, we need to use this idea, n times n plus 1. You could also write this as, if you were to multiply it out, n squared plus n. N times n is n squared, n times 1 is n. This would be how you get the nth term. Nice. So that's not easy, right, to develop those general formulas. Very much more an algebra-y topic, but so it goes. All right, last one on this video. Let's take a look here. Use a conjecture to make a prediction. Based on the data in the table, how many residents would you expect to vote in the 7th town council election? So in this table here, right, we have our year, we have the total residents given, and we have the number of voters. And we want to know about what number would go there. That's our question. So what I did in this problem was I looked at a couple different ideas here, right? So I looked at how these change, right? How the residents change and the votes change. So if you were to take 3511 and subtract it from 3790, you would get 279. And if you subtracted 414 and 386, you would get 20. I think that's 28. Do the same thing here, right? So 4085 minus 3790, I get 295. So I'm trying to develop a pattern, right? Maybe it's a subtractive pattern. And then if I did 451 minus 414, I got 37. So those are kind of similar-ish, I guess. So, maybe they're growing by about 275, 300, and this is growing by about, 30, 35. Let's do the next one. Well, the next one, when you do the change, it's 822, and this is 93. And wait, that definitely does not fit the pattern, right? The pattern just kind of jumped up. So I'm going to stop there. So I don't think that it's not an addition subtraction pattern. So that's the first thing I did here. So the first thing I did here is it addition or subtraction? So now I'm going to look at, what about a multiplication or a division, right? Multiplication or a division pattern. So let's go ahead and divide these, right? Let's take 386 from the first row. So this is the first row. Let me organize this better so you can see. So let's take the first row for the first year. And let's do 386 divided by 3511. I did this ahead of time, but if you do that, you get like 0.11. Let's do the same thing with the second one. 414 divided by 3790. And again, you get around 0.11. Third, 451 divided by 4085. And this is where the addition subtraction kind of changed, but here you still get 0.11. So I am believing, right, that each year, what this 0.1 represents is that each year about 11% vote. Now this is total residence. I don't think it's total voter registration, but that's pretty sad, right? If only 11% vote, voting is very important. Okay, so you should vote. So to find how many voters there would be in the 7th year, we're going to take the 7,786. So to find our question mark, and we're going to multiply it by 11% as a decimal. When you do that in your calculator, you get around 856. So we think that in the 7th year, there's going to be 856 voters out for that election. Okay, let's stop the first video here, and I'll make the second video in a second.